On air.
Yeah. Hey, everybody. Welcome to Urban Sensor Hack. This is our exciting final broadcast. We've been coming to you guys live for the last few weeks, twice a week, talking about sensor technology in urban environments and also monitoring a group of teams who've been participating with an array of sensors and components that we've supplied to them. They've been sending us information to our community page, and today we are going to check in with these teams, a few representatives from some of the teams, and see what they've built. But first, I'm Mike, executive editor for Make Magazine. As always, this is Stuart Gaines, longtime DIY editor.
Nice to see you guys. And I wanted to just thank you for participating on the community page. It's really been gratifying to see how many contributions we have. There are almost 300 members now on the community page. People have been supplying not only their projects but their ideas and their comments. Some people have been asking for help as well, so it's really been a community in every sense of the word. There were some ideas that people floated that got built and some ideas that people floated that didn't get built, and that's the whole point of a community. So we're really excited about how this is developing over the last 3 weeks, and we're looking to keep it going beyond this.
Absolutely, yeah. So if you guys are watching this live right now or watching it archived at some point in the future, you can always go to makezine.com/urban-sensor-hack, and that's our main homepage for this program. But there's also on that page, right towards the top, a nice orange button that links you right to the Google Plus community where all of the participants have been showing off all of the projects they've been working on. And feel free to keep those posts coming, pictures, questions, updates, comments, and we'll have people monitoring those, and the conversation will continue to go on. We're excited about it.
Yeah.
It's been a great response so far, and this is a really fascinating field, lots of fun stuff that we've seen over the last few weeks, and there's lots more to come.
And thanks too for the people who have uploaded videos. I think that's really really a good use of the technology to make a video of what you're doing. It really helps people understand what it is that they're looking at and how it works.
Yeah, absolutely. So in addition to 4 of the teams' representation that we have today, we also are joined by Alistair Allen and Kip Bradford, who, as you guys who've watched some of the other broadcasts know, are some of our master makers. They've shown off some of the incredible pieces that they've worked on themselves, including the Google Sensor Hack project that was in New England a few months back, if I'm not mistaken. So Al, Kip, do you guys have any things you want to chime in before we jump into these projects?
No, I'm good. Kip?
I'll just give the 5-second update. So since my last appearance on the Hangout, I've designed and manufactured 30 of these new sensor boards, which use the XBee wireless to transmit data back to a central computer. It also has an antenna to detect RF energy, air quality sensor, a microphone, and a temperature sensor, and a motion, little SparkFun PIR motion detector. These are like the boards that we did for Google, only they use 10% of the power because I use the Texas Instruments MSP430 as the processor and programmed it in Energia, which is an Arduino, based on Arduino, and lets you program the low-power TI parts. So
that's to run the same code we ran at I/O.
No, this is different code. This is actually, instead of using a mesh network where everything is kind of asynchronously controlled by the devices, this uses a master-slave topology. So there's a central hub computer which queries every one of the sensors and allows the central hub to control the flow of data and also control when the devices are on or off. So the devices can go into a deep sleep mode where they're battery powered, unlike the Google boards, which had to be plugged in, which is an entire whole logistics issue trying to plug in 500 devices in Moscone West as the whole crew that Google had was installing the Google I/O conference.
I still have nightmares.
Yeah, so these new battery-powered devices are fantastic because it shows people how you can create your own simple sensor circuit board design that uses low power and is battery powered, and you could put out in the environment and have it last for days or weeks or months. And those designs are open source.
So is that a simple star topology as we discuss in the book?
This is the simple star topology that is discussed in our book. So it's the I'll call it the name that other people have called it, which is the KIP mesh. It's just a silly topology that
no one else calls it KIP mesh except you, Kip.
I call it. Yeah. So people who I've worked with, other than Al, call it the KIP mesh, but it's just a piece of software that lives on the Arduino or on the MSP430, which allows the master to control the behavior of all of these devices rather than have the firmware on the radio control the behavior of the devices. But it's a very, very powerful thing, but is also about 5 lines of code. So anyone can do it.
That's great.
So that was distributed network data, which is one of the books that came with the Urban Sensor Hacks kit.
Yep, and so Al and Kip both had books that were part of the kits, as well as the KIP Kits sensor pack, which will include some of the pieces that we'll see from some of these teams. Kip, before we jump into the presentations, you right before the broadcast went live, you were showing us the layout of these boards. You're coming normally Kip's based in Rhode Island, and Al Zaire is from Exeter in the UK.
So I'm in Atlanta right now, and I'll show you my hotel room bed at the Online News Association conference. So all the big news organizations like New York Times and Reuters are here. We're outfitting the conference with 30 wireless sensors. So you can see these sensors laid out on my hotel room bed. In a couple hours after I get off this call, they're going to be spread throughout the Marriott Hotel here in Atlanta, and we'll be collecting data about the conference that WNYC is going to be publishing. I don't know if it's going to be live to the public, but it'll be available to the public after the conference.
That's awesome. Great. Well, I'm going to be looking for that. And I'm also going to look, Kip, to talk to you some more about these boards you put together, because this is stuff that we need to discuss in more detail through Make and everywhere else. Very cool.
Absolutely.
Great. Well, let's jump in and look with what types of projects these teams have done. The first one, we've got a whole list, a collection of makers that you guys can see below on the window here. But let's jump over to Jeffrey Stoll, who's coming to us from the Netherlands, just a little ways outside of Amsterdam. And he has got a project that he's been working on. You can see some of the updates on the Google Plus page. But Jeffrey, thanks for participating, and tell us about what you've been putting together here.
Yeah, I'm gonna switch on and get some slides over. So I'm gonna tell a story with it, because I think that's one of the things that Alison also mentioned, that in the end it's about telling a story. And
yes.
Let me see where it is. Yeah, so this is my story about participating in the Sensor Hack. You guys have it full screen?
Yep.
Okay, great. So my name is Jeff. A short introduction from myself. I'm pretty new to the maker scene. Less than 2 months ago, I just read something about Arduino and Make and visited the site. And but I'm a tech and a data dude, so I got started pretty quickly. And a long time ago, I studied aerospace engineering, so I have some technical background, and I still work as a data analyst in my day-to-day job. So I was very interested in participating and looking at data and getting data across, also for my day-to-day job. So yes, it has been a mental roller coaster participating in this sensor hack. First of all, it started with some unbelief with me that, you know, a magazine in the US was willing to send a pack over here to the Netherlands with some gear in it to start playing with it, while I just ordered my Arduino, my own Arduino, a week before. And here in Rotterdam, it's another city nearby, there's a makerspace starting up, and I had a chat with the guys over there, but we couldn't get enough people aligned to participate in this full time, in this such a short notice. So the waiting started until the FedEx dropped off the package. There was a delay in there. It was FedEx who couldn't find my address, so that resulted in a bit of frustration on my side, because I wanted to get started and I wanted to know what was in the kit so I could design with it. Because at first I had an idea, like the bike you see on the left, is to make a sensing bike, to drive around with some gas sensors, GPS, link it up to my Android phone, and then broadcast the data out there somewhere and make some nice fuels out of it. But maybe that was a little bit too much for a guy who's new to Arduino and sensors at all. So I simplified it and looked at at what was in the kit. So I started with some thermistors, and then I had really no clue how to work them really nicely. So fear started to hit me because there was just, let's say, a week left before today, and we had to present our final stuff. But in the end, and that's today, I'm pretty proud because I got it done. I skipped the thermistor, I ordered some other parts, and let's say the final result is a remote sensor. And what it does is that if I'm in location A, I'm very interested to know what the temperature or humidity is outside another location. And I don't want to walk over there because I'm also pretty lazy. So I want to have it linked up wirelessly out there. So what did I do? I have two Arduino Unos, some breadboards, some wires, and I built a base station that we put on location A. And I built a remote sensor that we put in location B. But I also want to be able to see in both locations what actually is happening. At the location itself, where I sense, so at location B, I just want to see the actual temperature and the actual humidity. But if I'm back at location A, I would like to know if humidity is increasing, it's decreasing, and the same goes for the temperature. So this is my kit and how I put it together. You'll see that I put a TFT screen on there. It's a 160 by 128 display. It communicates over the SPI bus, which basically is a bus that offers you 4 wires, of which 3 are common to link up multiple devices. So that's very handy to make use of the number of ports or the pins that you have on the Arduino. It updates every half a second, and what you see is a plot of around 25 seconds on the screen and the actual readings. So the temperature is plotted in red, and humidity is plotted in green. And what you nicely see there is the 4 dots, so about 2 seconds. That's the timing interval of the DHT sensor, which measures about every 2 seconds its measurement. And then I used not the XB board because it was not part of the package that I received, and I got a pretty cheap nRF24 chipset on a board. It's very cheap. I think it's less than $5, and it also communicates over the SPI bus, and the speed goes up to 2 megabits actually. So that's pretty fast out there. Then what you see is the sensor. It got the simple 16:2 LCD display on it. That was part of the controller pack. I had to do a little bit of soldering on it, which was also new to me. So it's been a journey, really learning a lot of stuff. And then the DHT22 that also been in some of the other demos and the other hangouts.
Great. Yep.
So before I jump to the live demo of what it is, I also like to share you what I found out during my journey learning. It was just like real life, If you don't know it, Google it, and Google has the answer. And what I found out that I also have to check my pins. I have to check them again and then another time, because you can really waste hours with a TFT display running and a wireless sensor not running, where you just have connected one wire the wrong way. So I learned for that and use a bit of paper to sketch stuff out before connecting it. There's a lot of coding examples available online, so you can just copy and paste a lot of examples, alter your code for your example, and then get it running. And what I found pretty helpful, and there's a very active IRC chat channel available, where you can just ask questions. There's always, let's say, 5-6 people in there who are very actively, and you get instant feedback. And when it's late at night or early in the morning, that's pretty handy to get you moving on your project. And I really like the Google Plus community. but I'd rather seen a lot more people actively participating in it. Although it was used actively, but I'd like to see a bit more activity in it. So next steps from my point, let's make it mobile. As you see, it has a lot of wires here. So put some casing around it. Going to add some gas sensors in it. We'll add the Bluetooth chip. It's on its way. I ordered it. I'll be building an Android app that communicates with it, and then finally push it out to do some graphing and charting on the web. So now, time for some live demo. So I'm going to switch over to my mobile cam. Hopefully you can see it. Let me get it lined up. So what you see here is the base station. It's switched off now, so I'll switch it on. Put some power on it. Okay, there it goes.
Okay. Yeah.
Is it visible?
Pull it back a little bit. It looks like it says Urban Sensor Hack right there on the screen.
Yeah, it says.
Fantastic. I love that.
Yeah.
It's a nice inclusion.
So what you see right now is an empty display. And now let me switch on the remote sensor. And what you'll see is that now the values are coming in. And the graph actually is being plotted. The green line is the humidity as percentage. And the red line is the temperature in degrees Celsius. It's pretty stable, as you see, so I'm going to do some heating up of the sensor. Let me see where it is.
And if those of you guys who are watching right now at home are unable to see this, because on our end we're able to see this fine, but it may not. This may not be transmitting through the Google Plus. But we're getting a nice graph. You can see the TFT screen, red line moving across the green line, which is on a downward slope.
So you see the humidity. I blow it into the sensor.
Yep.
So it got a peak, it spiked, and then it's going back back again. So now moving in towards the sensor, what you see is the 16:2 display showing the actual measurement. The famous DHT22 sensor with a 2-second delay, and there it is. That's my RF module, and there's a same module at the base. So that's basically my project in a nutshell. Also, I would like to thank the Make guys, the master makers, and the support staff for sending it out. You know, it was a great experience for me. It was a roller coaster. It was a steep learning curve, and definitely, if you plan another one, I will join again because I like the way and this kind of participation. It's my way of learning.
Great, thanks, Jeff. Yeah, and I appreciate you putting together that slideshow too. That's a nice touch. Fun to see how this journey's been for you, and some good feedback in there for us as well. Yeah. So that's great. Looking forward to seeing you continue working on it. This Android app, that's a big undertaking as well. So it's very cool.
Yeah, Jeff, you mentioned you're the Bluetooth board shipping. What type of Bluetooth are you using? Which board are you going to use?
It's one of the Chinese one from Duo Extreme. So it's another one. It's electronics on a budget.
Is it the Red Bear Labs board, the BLE Mini board, or?
I don't have it at hand. What it is? I looked up a couple of one, and this one got at least a lot of reviews on it. That it was pretty easy to link up with the Arduino. Mm-hmm. So once it's in, I'm gonna play around. With it and see if I can get it working.
Awesome.
Yeah, very cool. Well, thank you so much. It's great. I'm so glad that you shared this journey with us, and it seems like you're off to a great start.
Okay.
Impressive. That display looks great. The interface is awesome. So
yeah, good luck, Jeff.
Yeah, 2 months. That's
really 1 week.
Yeah, well, really 1 week.
Jeff, what was the IRC channel that you used?
It's hashtag Arduino.
Got it.
Great.
And hashtag electronics if you want to know something about the electronic part.
Awesome. Cool. Thank you, Jeff. Very cool stuff.
Guys.
So we're going to jump over to Manny in Chicago. Manny, you're with Monkey Bars. It's an event company that works on a lot of different types of things, but one of them specifically is hackathons, which is really a pretty interesting concept. So why don't you tell us a little bit about yourself and about the project that you've got underway?
Yeah, definitely. Well, first of all, thanks for all the sensors and all the Arduinos. It's been fun messing around with them. So, as you said, Monkey Bars is an events, logistics, and planning company. We focus on hackathons. And we have an event that's coming up in about a week and a half, October 26th. And it's a 28-hour hackathon being hosted on the campus of IIT, which is a college in the south side of Chicago. So, because we have a lot of teams that are coming in, because we've had a lot of reviews and obviously some feedback from previous events, we decided to use all the sensors and kind of, I guess, correlate certain variables with like team productivity. So we're deciding to take a team composed of professionals, obviously people that have been in the industry for more than a year, 2 or 3, that work for a company, and we're going to give them the infrared sensor, the motion sensor, the temperature sensor, and the particulate matter sensor, and just kind of see how those variables plot over time, compare that to their commit logs, compare that to their network traffic, and then see if we can find some kind of correlation and maybe, see if that relates to productivity, or see if there's anything we could like switch or tweak in our future events to make it a little bit better. So I don't have a lot to show. Obviously, it's just a lot of quick soldering. Our shields are complete, and that's about it. Some of the code is working. We're still working on the rest of it, but it's been a bit of it's been a little hectic trying to finalize sponsors and get teams ready to go. But yeah, ultimately, I guess I have a really quick graph here to kind of show we'll be planning a couple of things together, and then see if all that relates to a better event in the future.
That's great.
Yeah. So if there's any questions, please feel free to shoot them out.
So one of the things I was wondering about, and we mentioned this for a moment earlier today when we were discussing your project, but measuring the productivity of the teams, that itself seems like a pretty big undertaking.
It is, and I guess from a personal note, productivity seems a bit subjective. So what we're going to ask this team is to kind of state a couple of goals they want to have accomplished by the end of the hackathon. So if they have 4, 5, 10 goals, at the end of the hackathon, we'll be able to accomplish 5 of them, all of them, 2 of them, and kind of use that as a measure of productivity. Obviously, the more goals they accomplish, the more productive they have been. Otherwise, it wouldn't be. But yeah, that's what we're thinking.
Great. And this Forge hackathon, you said it's October 26th?
October 26th to October 27th. It will be at the Idea Shop. In case anyone's in Chicago, you're more than welcome to attend. Doors open at 10 o'clock. The address is 3440 South Dearborn. And walk in the doors and head down to the basement. It's a really awesome space.
And what did you say? It was 3440
South Dearborn.
South Dearborn. So yeah, those of you guys who are watching and are in the Chicago area and are interested in participating, feel
free to stop by. Walk-ins are more than welcome.
Yeah. And Manny, would you repeat just what sensors you're planning to measure?
Yeah, we'll be dropping in all the sensors that you provided. So the motion sensor, the temperature and humidity sensor, the sound sensor, and my personal favorite, the particulate matter sensor. If I could find it lying around here somewhere. Here it is. So once we get it all wired up, we'll put them into little containers and hand them off to the team and see what happens.
Yeah. Well, if we had known about this project ahead of time, we could have included a breathalyzer.
Oh, that would have been awesome.
That would. I think I've got a prediction on productivity output.
Right.
Yeah, that's great though. So yeah, please keep the community page updated on the project as it comes together. Just have a personal curiosity always in case choices. So as you guys decide, I don't know if you have something in mind, if you'll use a stock case encasement, or if you'll be 3D printing something. That's always interesting to me because there's a lot of.
Are you going to publish the data afterwards?
Yeah, absolutely. I'll make all the data public, free for just for everyone to look over.
Cool. Very cool. Well, thanks, Manny. And yep, keep us filled in.
Yeah, absolutely.
Looking forward to hearing how the event goes.
Thanks a lot, guys.
You're welcome. Next up, we've got Christopher Hills, who's in Brighton, part of Build Brighton Hackerspace, and in Brighton, England. That correct. To make that clear. This is a nice international group we've got here.
It is.
Yeah.
It is.
Yeah, down on the south coast of England. And my name's Chris Hills. I'm from Bill Brighton. I've been a maker for about 2 years, and I've been made various projects. And I've got 2 projects which are temperature and humidity related that I've used, and how I used the parts that I was sent in the box. So I'm also coming from a live Hackspace. This is, I'll give you a quick demo, or a quick sort of move around on the camera. You can actually see that we've actually got a big, large hackerspace here. This is just one block. This is just one room. There's another room opposite the other wall. There's a wall here, which has got a workshop behind it, and that's got loads of tools, lathes, laser cutter. Am I thinking about?
And it's about 12:30, half an hour after midnight out there, but there looks like people are busy at work still.
Yeah, we don't normally, on a Thursday night it's our open night, and we don't generally leave until about 1:30, 2. So it's quite, because we find that after 12 o'clock is when the magic starts happening and stuff starts to work and the project sort of comes together. So I'll start with and the reason I sort of wanted to set this project up was because we've got a laser cutter which is water cooled by a tank below it, and we want to monitor the temperature of the water. So it's kept at an optimum temperature. So I've actually got a waterproof sensor here, which is this thing here. You can see it's basically a one wire Dallas sensor inside the steel tube. So you can actually put it inside a liquid. And here's the actual display, which is a 2-digit 7-segment display being driven by 2 shift registers. So and if I then stick this temperature probe in some warm water, you should notice that it's actually going up. It's now saying 23, 24, 25. So that would be, and we can then put it on. What my plan is with the little maker shield that I got, and I put together, I'm going to squeeze all the components on the breadboard onto this shield. I can then put that on top of the Arduino, and then we can put it by the laser cutter, and then use it as a platform for other sensors or make air quality, so we can actually, check the air quality around the laser, so we're not doing in sort of bad fumes and stuff.
Great.
And that's all powered off the Arduino there. But the other one I've also got is over here, which is like a temperature humidity. I mean, that shows you the page details of where the actual feed's been uploaded to.
Okay. Oh yeah, there you go. Got a Xively.com link there. People can capture that info. And did I see a QR code above that?
Yeah.
Come down just a little bit. I'd be curious. I'm tempted to pull my phone out and see if I can read that QR code over the broadcast here. But so that I'm assuming directs people to the Xively the Xively post that you've got where you're capturing the data and displaying it.
Yeah, it basically uploads the data every 5 minutes, and then there's also a LCD display which shows the actual data in real time. And you should see it's about 20 degrees, 20.9, and it's about 65% humidity.
Not too bad.
Yeah. It's actually been quite damp in the last month or so. We had quite a lot of rain. It's normally about 50, 40.
Okay.
But it's quite damp in here at the moment. My 2 projects, and that's running on there's an Ethernet shield on top of a Dumili Nova, which is like the Arduino that's before the Uno on that version of the Arduino board. I had it sort of lying about, and I couldn't really afford to buy any more new parts, so I used what I had.
Gotcha. That's the maker spirit, really.
Yeah.
So so the Ethernet shield is what's driving the data from your sensor out to the website.
Yeah, I've got all the Arduino libraries are running on the X-Library Arduino libraries are running on the Arduino, and that's uploading the data to the website and then grafting it. So it's actually giving you a graph, and you can look at it over time and you can see all the troughs and how you can see the relationship between temperature and humidity, about how the temperature sort of goes up and the humidity drops. So you get that relationship, and it's quite. We've sort of checked out the temperature sensor, and we say it's fairly accurate. We've measured it with a commercial bought temperature sensor, and it read the same, but we're not quite sure of the accuracy on the humidity to see whether that's it is actually 60% or it's fairly accurate.
Yeah, I don't know if Kip or Al, if you guys have any feedback on the accuracy. From what I understand, it's pretty spot on, but
for temperature,
for the humidity aspect.
The DHT22.
Yeah.
Yeah, it's pretty accurate. I could look up the exact figures, but the tolerances are pretty good. It's a really nice sensor.
I mean, it does mention it on the data sheet as 1 or 2, plus or minus 2%.
Yeah, most of the commercially available temperature sensors these days are you can get very, very, very accurate for not a lot of money. So most sensors are going to be plus or minus 1 degree centigrade in that range. Some really cheap ones are plus or minus 1 or 2 centigrade. If you want to get into the 0.1 centigrade range, then you start to pay more, and you have other issues like signal quality. But the DHT22 is a fairly decent device, and there are a lot of good temperature sensors out there that are really easy to use.
That's great. So, Christopher, what's next with this project? Anything that you've got planned that you continue to work on with it?
Well, I'm going to squeeze it put it onto the actual shield.
Yep.
That's my next task, and then I'm only using 3 pins on the Arduino for this power shift, so I'm going to basically make it so there's a proto board attached to that Arduino as well, and then use that to put more sensors on it, and use the LCD, and put some air quality sensors on there when I get hold of one, or maybe put another temperature and humidity, and then make it so it talks to the other device, or we have set up a central server at the hack space, so it takes the temperature. So it basically centralizes all the data in one place, and maybe have a screen which has got this is the temperature in the workshop, this is the temperature in the main space, and this is the temperature outside, and the air quality as well.
Yeah.
That's the long-term plan. But
I like it. I think that if you can factor in somehow, maybe you and Manny can talk about this, but a productivity measurement, you can have an international system here where you're comparing different environmental conditions and productivity output.
Yeah, okay, maybe, yeah.
Yeah, I was going to say,
sounds awesome.
One thing I did notice when I first bought it is we've had quite a warm summer. We've actually had quite a good summer this year compared to what it's normally like in the UK, and the temperature didn't drop when I first installed it. The temperature didn't drop below 20 degrees, and I just didn't think that was. I thought the sensor was faulty, and I ended up sticking it outside and trying to get it to go lower because it was just too 20 degrees is just too warm.
How was your productivity?
During the summer it's like 20 or 30, and I may even put some maximum, change the LCD so because you notice there were a couple of arrows on it, and I've done some custom characters. Maybe make it so that they go higher and lower. So when the actual temperature starts dropping, it actually shows you on the screen that it's the system's, the actual temperature is dropping.
Yeah.
That'd be by flipping do some code, do it in the code and actually have the custom characters showing it's going up and it's showing down. Flip the arrow basically.
Good stuff. So you guys, Build Brighton, you guys have a website, buildbrighton.org? Yeah,
that's our website, yeah, and you've got details on there, whereabouts we are, and directions on Google Maps. And our open night is on Thursday nights from 7. So if you're in the area, you can pop in, talk with everyone, bring your ideas along, do a hack, join up. We give you a guided tour of the space, show you the tools we've got, and generally help you along with your projects. And there's quite a lot of cool people here that do some really cool stuff.
That's awesome.
And it's just really good to get I've built another little, I mean, I've also got a little Arduino powered car that if you look at my Google Plus page.
Oh, good. Okay. And, we'll link your Google Plus page to the community.
Yeah.
Oh, we don't see the PowerPoint. Okay. We are yeah. Sorry about that, guys. We are we'll link the Google Plus page onto the site, onto the community page, so people can go there and see the Arduino car and everything else. But yeah, great. And
Chris, can you turn off your screen share?
I didn't necessarily realize it was on.
No, I think it's what happened is that it's backlogged, so they're seeing from a couple minutes back.
Okay.
Yeah.
Okay.
So, super. Let's jump forward and get over to Thomas Amberg, who has one of my favorite projects, the Timid sensor. So, Thomas, where are you coming from again?
Hi, I'm from Zurich.
Okay, Zurich. From Zurich, great.
Yeah,
again,
in Switzerland.
Very, very international community here.
And I represent the Internet of Things meetup group in Zurich that I'm also organizing. It's got about 370 members, something.
Nice.
And also a hack space called Mechart Lab in Swiss German.
How do you spell that?
Yeah, just a second. So here's the link.
Here we go. So it's mechatronic.ch/mechartlab. And we'll put this on the Google community page for everyone to click into and read about that, as well as meetup.com/IoT-Zurich.
Thanks.
Very cool.
Yeah, and at this meetup group and also at the Makespace, we build stuff like this. It's an alternative air casting sensor. You had air casting in a previous Hangout, and it's made from laser cut wood. So yeah, we try to use other projects and work together.
Do you mean the sensor or the enclosure?
Yeah, it's both.
Oh, okay.
It's a sensor and it's made with different. Here you can see the inside maybe. It's made with another system of open hardware, with this Gadgeteer system. So yeah.
It's very cool. Yeah, that's an interesting design too, and it looks you know, I think there's a lot of interesting things people are doing, laser cut art and finding actual practical applications for it too. I haven't seen a ton of that yet, but that's very cool looking.
Okay. Another collaboration of this meetup group is the Internet Connected Beer. The project is called Oktoberfest of Things.
Oktoberfest of Things, I love that.
So, and yeah, for this project we thought about sensors in the city. And often such sensors, like the official ones that the government places, are ruggedized, and they are placed high up, so they are out of reach of people. And we thought about another strategy for sensors to survive in the city. So we thought they have to look more boring and uninteresting, and just expose the sensor shortly when they want to take a measurement. So it's a bit like a snail that puts out the stalkers and then retracts again once it's done its snail business. So I tried to get this working. We had a nice package including servo motors. So there's one of them is inside. Then there's a little laser cut adapter. There's an Arduino, a brightness sensor, some LEDs for the looks, So let's see. So the egg is just sleeping, and then once in a while it takes a measurement. And how this works is that we use a phone as a gateway, and there's also a Bluetooth module inside of the egg. So this sends out measurements to the phone and from there to the internet. So you should be able to see the measurements. I just send you the feed. And there's a chance that it doesn't work for a long time because the battery is almost empty.
That's great.
Yeah, so maybe we can have a look what's inside. I'll just take it, rip it apart, and we'll see how long it transmits measurements.
Okay.
Yeah, please.
So, and this is made out of a cheap. I have to send you also this link. It looks so nice. A cheap tabletop trash bin from a dollar market, you could say.
So we've got.
I was wondering whether it was an IKEA bin.
So here's the inside. Can you see that?
Yeah.
The LEDs are just for the looks.
Okay.
It has to look somehow mysterious inside. So, and yeah, it's not the best camera. Here you see the laser cut adapter for the metal. So that's how it was fixed inside this thing, and it's still alive somehow.
Yeah.
And yeah, there's lots of cables or of wires for just a little effect of the LEDs. And
Thomas, what is the sound that is creating?
That's a servo.
Okay.
And it does a few steps in a loop, so it sounds a bit more like an animal.
Yeah. And you said that the sensor itself is detecting the level of brightness.
Yeah, it is. So we should be able to test this. Here you can see the Bluetooth module. It's a Blue Smurf. Module, an older one from SparkFun, but very easy to use. And the main problem right now is, of course, the energy. As always, the included battery holder was for a 9-volt battery, and this is just not enough for a long time of operation of this egg. Yeah. So that was the project we did, and for the future, can you hear me?
Yep.
Yes.
Yeah. Keep going.
Okay. For the future, we plan to use other, because this egg is not really camouflaged in the city, but maybe something like this. So this, the sensors could just peer out and then close again, something like this. And you could place it into a hole in a wall.
Absolutely.
So it's really undercover.
That's great. That's a really creative approach to ways to set up a fun sensor network. I love it. That's funny.
They talk to each other, and yeah, they don't.
Yeah, it's maybe a little bit more about the thing side of the Internet of Things and less about the sensor or the Internet side.
Right, and it makes sense because coming from the Internet of Things community there in Zurich, that's incorporating that aspect and element more directly into your build. That makes perfect sense.
Yeah, and as a job or let's say as a startup, I'm working more on the internet side. So there we do the connection to the thing, and yeah, this is just to keep the balance.
Got it.
Where do you imagine?
And if we still,
Tomas, where do you imagine these little shy trash can eggs will be deployed?
One real problem I had is that I like to go swimming, and I swim in a river in the city, and therefore I built a little lap counter so I can count laps. It's also connected to the internet.
Not surprisingly.
Yeah, as everything. And just a second. It's an old project, but maybe it's still fun to have a look. And yeah, there I thought about mounting this this lap counter to the border of the river. And yeah, I'm not sure how long it would stay there, if it's obviously an expensive thing. So this was the reason to start thinking about that.
Cool. Well, I encourage you to continue working on that. I'm not a very good swimmer.
You took your Oktoberfest thing to Maker Faire Rome, right?
Yeah, also.
Yes.
Exactly.
Yeah. Yeah, I love that.
What did the Italians make of it?
They said I should not make a product out of it.
They didn't make you attach it to an espresso cup?
That's so funny.
If we have one more minute, I could show another cheap hack. That's maybe fun. It's a temperature display that's connected through Wi-Fi to the internet, and it shows the temperature of my favorite river where I swim.
Ah, great.
It gets this temperature also from Patch Bay or Sibley.
For the Americans in the audience, that's in Celsius, by the way.
Yeah.
Yeah, but it's very cold. I would never swim now.
No.
But maybe the main thing is that it's made with an e-ink display, a huge one.
Yes.
So low power. Yeah.
Yeah, it's low power and it's very ambient. You can just keep it on the wall and it's like a watch. It's not like a display that disturbs you. And the main point about it is that it is a really cheap hack. So it's really just a Kindle 4 inside a nice enclosure. Yeah, that's all for now.
Great. Well, thank you, Thomas. That's fun stuff. Really cool
very
stuff.
creative and playful. I like the playfulness of some of these things.
Yeah, absolutely.
Yeah.
Thank
you. I saw one, I might throw a little piece of trash in it, though.
So, yeah, I want to thank everybody, not just today, but definitely today. Thank you all of you guys for participating, but thanks to all the master makers who've been on air over the last few weeks. Thanks for everyone that's been watching over the last few weeks. Thanks for all the teams who've requested our sensor kits, and keep the communication and the community going. We've got a great start here, and I'm excited to see what comes up next. So all of you guys, definitely,
Absolutely.
Everyone that's watching, remember the website is makezine.com/urban-sensor-hack. Pretty straightforward, urban sensor hack, and from there we've got information about what we've done. Also, that link right to the Google Plus community page, which is got a lot of information.
Yeah, and also thanks to our sponsor, GE.
Yeah.
For making it possible to send out these kits, and I really think that what we got back was beyond the realm of imagination. It was really great.
Yeah, some fantastic stuff. Thank you again. Yeah, sponsors, that's awesome, and participants
and our masters. And I really like. I remember, Alistair, from the first one, the idea about the story. I think what we heard tonight was a number of really interesting stories.
Yeah, absolutely. So
yeah, when it comes down to it, it's not technology; it's about the story. It's what you do with it and the story you tell, right?
That is the goal. And sometimes I'm struggling to learn that one because I find myself buying stuff unnecessarily without stories to tell. But ultimately, that is where the best outcome comes from. It's not the technology; it's the story that you tell. Nicely said, Al. So this wraps everything up.
Yes.
Fantastic. And keep things moving.
Thanks to you, Mike.
You too, Stuart.
Great job that you did.
Well, likewise.
Yeah, very sensitive.
Yeah. We'll be keeping ourselves active on all these the community pages. So
cool.
yeah.
All right.
Take care, everyone, and
Bye-bye.
see you next time.